Hello viewers, in today's class we are going to discuss one important concept in three-dimensional geometry, right? So viewers, here we are going to discuss one problem related to intersection of plane and line, right? So we have already discussed in detail regarding the plane and line in our earlier videos, right? So you can for more information you can go through those videos, and here we are going to solve this problem, which is a very important problem in three-dimensional geometry, having the concept of intersection of plane and line, right? So here we have to find the distance of this point from the point of intersection of this line and this plane, right? So here we are given this point, say A, which is 2 comma 12 comma 5, right? And we have to find the distance of this point from the intersection of this line and this plane, right? Suppose we have this plane, and let us denote the plane by pi, and we have a line, say this is the line, right? So here we have the line, and here this is the point of intersection of this line and plane, right? And we have to find the distance, say this is point P, which is the point of intersection of this plane and the line, and we have to find this distance, right? Okay, so now what we will do here, we have to find the coordinates of this point P, right? Because once we know the coordinates of this point P, we can find this distance AP by using the distance formula, right? So let us first find out the point of intersection of this plane pi and the line L, right? Okay, so now here we are given the vector equations of the line and the plane, right? So here what we will do, we'll convert these equations in the form of Cartesian equations, right? So the line L can be expressed in terms of Cartesian form as x minus 2 over 3 and y plus 4 over 4 and z minus 2 over 2, right? So this is the Cartesian form of this line, which is given in vector form, and the Cartesian form of this plane is given by x minus 2y plus z equal to 0, right? So these are the two equations, right? So here we have used the general form in Cartesian form, Cartesian system of the line, that is x minus x1 over a, y minus y1 over b, and z minus z1 over c. So here x1 y1 z1 is the point through which this line passes through. So here x1 y1 z1 are the points 2 comma minus 4 comma 2, right? So here 2 minus 4 and 2, and here we have the equation of the plane, and the drs of the line are 3, 4 and 2, and here the drs of the normal are given by 1, minus 2 and 1, right? Okay, so these are the informations which we can draw from the equation of the line and the plane, right? Okay, so now viewers, here in order to calculate the coordinates of this point P, which is the intersection of this plane and line, let us take here lambda, right? So here we are taking this scalar lambda in order to find out the general point on this line L, right? So therefore we have x minus 2 over 3 is equal to lambda, y plus 4 over 4 is equal to lambda, and z minus 2 over 2 is equal to lambda, right? Now we can solve these three equations to get the value of x, y and z. So from here we have x is equal to 3 lambda plus 2, y is equal to 4 lambda minus 4, and z is equal to 2 lambda plus 2, right? So x comma y comma z, x comma y comma z are the coordinates of a general point on the line for some value of lambda, right? So here for some value of this scalar lambda, we have this point P, right? So now we see that this point P, it lies on the plane also, because this point P is the intersection of this line L and the plane pi. So therefore P also lies on the plane, right? So when this point P lies on this plane, so it has to satisfy the equation of the plane. So for x we have 3 lambda plus 2, for y 4 lambda minus 4, and for z we have 2 lambda plus 2. So substituting these values of x, y, z over here, we get 3 lambda plus 2, then we have minus 2, 4 lambda minus 4 plus 2 lambda plus 2 is equal to 0, right? Now we have a linear equation in lambda. So simplifying it, we have minus 8 lambda, here we have 8, then we have 2 lambda plus 2 is equal to 0. So this is 3, this is 2, 5 minus 8 lambda is minus 3 lambda, and here we have 8 plus 2, 10 plus 2, 12. So now we have minus 3 lambda is equal to minus 12. So lambda is minus 12 over minus 3, that is 4. So for lambda is equal to 4, we have this point P, right? So therefore the coordinates of this point P are given by x comma y comma z, and x can be calculated from here, that is 3 lambda plus 2. So lambda is 4, so we have 3 times 4 plus 2, that is 14, and y is 4 lambda minus 4, so we have 4 times 4 minus 4, that is 12, and z is equal to 2 times 4 plus 2, that is 2 4s are 8 plus 2, that is 4 2s are 8 plus 2, 10, right? So the coordinates of this point P are 14 comma 12 comma 10, right? So now here we have 14 comma 12 comma 10, right? Now we can easily find out the distance AP by making use of the distance formula in 3 dimensions. So now viewers, the distance formula is given by this expression. Here we have AP, and AP is the square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square, and here we have this point can be taken as x1 y1 and z1, and this point can be taken as x2 y2 and z2, right? So now the distance is given by 14 minus 2 square plus 12 minus 12 square plus here we have 10 minus 5 square, right? So now we have 14 minus 2 is 12 square, here we have 0 square, and here we have 5 square, right? So this is 144. this is 0, this is 25, and here we have 169, right? And the square root of 169 is 13, right? So the distance is positive, so we'll take AB is equal to 13 units, right? So viewers, the distance of this point 2 comma 12 comma 5 from the point of intersection of this line and this plane is 13 units, right? So this is how we solve this problem.